Hi, welcome to another mini lecture on pre-calculus. Today's lecture is about finding coordinates on the unit circle for special angles. So let's see what is the issue today. So what is a unit circle? Of course, unit circle is a circle of radius 1. Okay, so radius is equal to 1. Next, we are going to be traveling on this circle. There are certain special landmarks. We are going to refer to them as special angles. They are kind of easy to work with. We are going to emphasize these locations now, and later on we are going to look at all the other locations as well. So you remember that we talked about radians, and we said if you take a rope the size of this radius and lay it on the circle itself, so this is 1 and this is 1, that angle was called 1 radian. As we go around the circle, we start at location 0 radians, and then by time we have come back, we have gone through 2 pi radians. That's essentially same as saying that circumference of a circle is 2 pi r. You remember? Circumference was 2 pi r. R is now 1, so by the time you have come back, you have gone through a distance of 2 pi. Well, what are special landmarks while you were going around? Well, of course, if I take this circle and divide it in half, by the time I have come here, I've gone through a distance of pi. Well, what if I take half of that? In that case, let's draw this axis as well. By the time I have reached this location, I am at pi over 2, and if I go an extra pi over 2, I'll be at 3 pi over 2, and once I finish the circle, I'm back at where I started at. I'll be at 2 pi. So we are going to remember like this 4 corners of the circle. We are at 0, pi over 2, pi, and 3 pi over 2. Now what if we add in some more special landmarks? Let me draw another circle so that our picture doesn't get too crowded. What other special landmarks can we consider? So well, I can go halfway here, and now halfway, this was 0 and this was pi over 2, so halfway is going to be pi over 4. I can go and divide this one by half as well in this one, like a pizza divided to 8 slices. So pi over 4, pi over 2, if this is pi over 4, this is 2 pi over 4, which is same as pi over 2. This is 3 pi over 4. Well, 3 pi over 4, it doesn't simplify like that. If I go all the way here, well, of course it's going to be 4 pi over 4, which we just write as pi. If I continue all the way here, it's going to be 5 pi over 4. 6 pi over 4, we simplify as 3 pi over 2. If I continue all the way here, it will be 7 pi over 4. Like by here, I have used up 7 over the slices. If I make it all the way back, well, 8 pi over 4 is same as 2 pi. So what we learned here is that these halfway points, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Well, what if I wanted to travel in negative direction? In negative direction, this would have been 0, this would have been minus pi over 2, this is same as minus pi, this is minus 3 pi over 2. By the time I have made it here is minus 2 pi. In this picture, if I go in this direction, I will arrive at minus pi over 4 here, minus 3 pi over 4 will be at here. Like again, this is 1, 2, and 3, and the negative direction makes minus 3 pi over 4. This becomes minus 7 pi over 4, excuse me, minus 5 pi over 4, and this becomes minus 7 pi over 4. Okay, what else? Well, we can consider another subdivision, which is going to be take this circle and divide it into 6 slices, which is sometimes the pizza shops do it like that. Divide it into 6. So if this was 0 and pi, a third of that, which will be this, will be pi third, and this is going to be 2 pi third, and then this is going to be this is 2, and then 3, and this is 4 pi third. So 4 pi third, and then if you come here, it becomes 5 pi third, and then 6 pi third. We are back at 0. If you take this and subdivide it in half, so now your divisions are at pi over 6. So this is pi over 6. This is same as what we had before, pi over 2. That is, by the time you come here, you're at 3 pi over 6, same as pi over 2. By the time you go 1, 2, 3, 4, 5, this is 5 pi over 6. 6, 7. This is 7 pi over 6. This is, of course, 3 pi over 2. And then here is going to be 7, 8, 9, 10, and 11. 11 pi over 6. So essentially we are going on a circle. So sometimes you can animate this thing and look at it. Let me see if I can find something for you. Here. So this line that you see here, this line, imagine this being a string, and we take that string and wrap it around the circle like this. So I take this. So what this picture means is that if this much of the string, this red portion, is wrapped around the circle, it comes up to here. Suppose if I go further, how far do I have to go until okay. Now the amount of circle I have used is equal to pi over 2. I'm at point pi over 2. If I keep going, I keep wrapping, going around, and now if you want to see what is the arc length, it says arc length now is that number. Let's go back to something familiar. At here, the arc length is pi over 2. Let's see if we can find something as familiar. Like here, we are at pi over third. That length of pi over third, if it is wrapped around the circle, is going to look like a picture like this. Okay, so that's step 1. We are going around the circle. You can think about somebody on a circular track and just running around, or you can think about somebody taking a rope and wrapping it around a circle. Well, that's one way of knowing where you're at, by just knowing how much of rope you have wrapped around this thing. Another way is giving x and y coordinate. For example, if I am at this location, I have an easy coordinate because my x is 0 and my y is 1, so I'm at the location 0 and 1. What if I am at the starting point? Well, the location there is 0 and 0. What if I'm at this point? Well, x is minus 1 and y is 0. What if I'm at here? So x is 0 and y is minus 1. So the 4 corners of the circle have very easy coordinates. Let me see if I made a mistake here. Looks like, let me correct it. And here I'm at the location, x is 1 and y is equal to 0. Is that right? So I overwrote something I had there. So 0 zeros obviously is just at this center. Okay, let's go to something more advanced. Suppose I have gone from this corner to this point. That is, the angle is pi over 4. Now the question is, what is the x and y of this point? This is the x of it and this is the y of it. What are these two numbers? That is going to bring us to the beginning of trigonometry. So what triangle are we looking at here? We have an isosceles right triangle. The hypotenuse of it is 1. This angle is pi over 4 or 45 degrees. What are these two? I'm sure most of you have seen this, but let's practice again. Suppose I don't know what this is. Well, this one is the same size because this is also pi over 4. Sum of them has to be 90 degrees or pi over 2. So now we apply the Pythagorean theorem. X squared plus x squared has to be 1 squared. So 2x squared is equal to 1. So x squared is equal to 1/2. So x is plus or minus 1 over square root of 2. Now our dimensions are positive here, so my x is 1 over square root of 2. And if I rationalize, remember we talked about this thing before, if I rationalize, I get x is equal to radical 2 over radical 2. So now since these two dimensions, x and y coordinate for me, are both same numbers, the coordinate of this point, let's write it here so it is less crowded. So if I'm going on a circle and I stop at this halfway point here where this angle is pi over 4, the coordinate of this point is radical 2 over 2 and radical 2 over 2. Okay, so this is coordinate of that. Well, if I go to the left hand side, my x becomes negative. So by the time I have come at 3 pi over 4, so this angle now is 3 pi over 4. The coordinate becomes minus radical 2 over 2 and radical 2 over 2. If I go another quarter turn until I come to this point, both x and y become negative. And if I go another quarter turn until I come at this location, so by now I have arrived here, this is 5 pi over 4 and here is 7 pi over 4. By the time I arrive here, x is positive radical 2 over 2 and y is negative minus radical 2 over 2. So for 45 degrees or for pi over 4, I know the coordinates of these four corners. Next, we want to know how about multiples of pi third, like this pi third, 2 pi third, 4 pi third, 5 pi third, and the other set also similar to that with pi sixes. What are the coordinates for those? Well, let's remember something. So if I have a triangle with angles pi 6, and this one will be then pi third, which is same as 30 degrees and 60 degrees. If I duplicate this, I get an equilateral triangle. So if this leg is 1 for my hypotenuse, this one will be 1/2. So what should this one be? Let me call it L so it doesn't mix with my other quantities. Well, of course, with the Pythagorean theorem, now we have L squared plus 1/2 squared is equal to 1. So L squared plus a quarter is equal to 1. So L squared is equal to 3/4. And again, L being positive, square root of this over square root of 4, which is 2. So L becomes radical 3/2. So what we learn here is an important triangle to remember. If I have this hypotenuse 1 and this is an angle pi 6, then this is going to be 1/2 and this is going to be radical 3/2. Of course, if I take this thing, turn it around, meaning put the smaller side down here and the longer side up there, it's going to be pi third, and this is going to be pi 6. Same reasoning as before. This becomes 1, this becomes 1/2, and this becomes radical 3/2. Now we need to essentially have this triangle memorized to simplify our life, and what it does for us is that it let me write it here. So if I go on a circle and stop at pi third here, and I want to know what is my coordinate in this location, I appeal to what we just said, that this quantity is 1/2 and this quantity is radical 3/2. So that means the coordinate of this point is 1/2 and radical 3/2. Once we have one of these points, the rest are easy to make. If I go to the left, it becomes -1/2 and radical 3/2. So this is at the angle 2 pi third. If I come down here at this point, so this is going to be 4 pi third. It's going to be -1/2 and minus radical 3/2. And if I come down here, so that would be 1, 2, 3, 4, 5. This is going to be at 5 pi third. And the coordinates now is 1/2 and minus radical 3/2. So we found out for pi 6, for these 4 point, what quantities we have for the coordinates of those. Let's do one more round. We have to do this. If we go at multiples of pi 6, so at pi 6 I'll be here. So this is pi 6. What are my coordinates? Again, this one is radical 3/2 and this one is 1/2. So up here we are going to have radical 3/2 and 1/2. If I go the other side, of course, are going to be x negative minus radical 3/2 and 1/2. Down here, so that one will be 5 pi 6. And this will be 7 pi 6. So minus radical 3/2 and minus 1/2. And down here we are at 11 pi over 6. The location would be minus radical 3/2. X is positive, of course. Radical 3/2 and minus 1/2. Now you all have these circles printed on a piece of paper, and you get used to looking at that for finding answers, I want to emphasize as much as possible, try to reason your way to the answer as opposed to looking it up. It is extremely important for you to build up an intuition about what these numbers are supposed to be, especially as you go around the circle, when it becomes which one of the signs flip, and so on. Okay, uh, one way or another, you're gonna memorize and understand all of these. Of course, in your notebook, you can have this picture, but again, to be able to follow the conversation, it would be impractical to go and flip your notebook and go back to this and try to reinvent the wheel every time. You do need to understand it and memorize it. Here are several problems here. These are all in radians, so problem is very similar to what we just talked about. 2 pi third radians. So how do I think about this? 2 pi third radians. Let's go back and try to uh, reason our way. So uh, where is 2 pi third? 2 pi third is here. 2 pi third, you can also remember 120 degrees, you'll be at this location. This is 2 pi third, that's the angle. So in other words, this is going to be 60 degrees or pi third. So the side in front of it will be 1/2, but since you are on the negative side, becomes negative 1/2. So this becomes negative 1/2. The side opposite is going to be radical 3/2, and that is positive, so this becomes radical 3/2. Again, the emphasis is try to reason your way to an answer. How can you make your life a little bit simpler? So let's remember the following. They're just essentially two triangles you remember. This is radical 2/2 and radical 2/2. And this is of course 1. That is for pi fourth. The other one, pi 6 and pi third. This is 1, this is 1/2, this is radical 3/2. So essentially it's just these two triangles that you need to memorize, and even there it's better for you to reinvent the reasoning for yourself so many times until you actually have this thing as second nature. Okay, let's go ahead and do again. This one, the angle is negative -5 pi 6. So let's get a little bit of help. -5 pi 6. Where is -5 pi 6? Remember, pi 6 is 30 degrees. So 5 of them is 150 degrees. Minus means I'm going this direction. I go as far as 150 degrees. I'm here. So this -5 pi 6. So we have to be absolutely sure which quadrant we are ending up in. So the way we reasoned is that it will be 150 degrees and we have 30 degrees left. Okay, now next we say, look, this is a triangle. This is the small side of it, that's pi 6. In front of that is 1/2, the other side is radical 3/2, but since we are in this quadrant, this is -1/2, so this one going down here is going to be -1/2, and this one going to the left side, that's going to be minus radical 3/2. The first one is my x and the second one is my y. So that one here is minus radical 3/2 and -1/2. Again, looking this up is not the point here. You have to reason your way one way or another to what the answer is supposed to be. So suppose you don't have your notebook, you don't have any websites to go to or anything, it's just you are alone on an island alone on an island in the entire world to care for coordinates of point on the unit circle corresponding to the angle of minus 5 pi over 4. Let me go back here and just what do we mean minus? So if I take this point and go down, it is as if I'm wrapping up the other direction. So as I go down, my location can be measured in terms of a negative distance. So this is negative pi third. If I take this much of a string and wrap it around my circle, I end up at this location. We are asking what are the coordinates of that location. So that's the x of it, that's the y of it. Of course, in this demo you see decimal approximations, but in your software it's asking for exact values, insisting not to give decimal approximation. So you have to be careful about that. Pi third, well, that would be the easiest of all of them. Pi third, we are at this location. This is 60 degrees or pi third. So the two dimension, this is going to be 1/2, and the other one is going to be radical 3 over 2. Let's just pay attention to some other special cases. What if I am at 0 radians? Well, we said that that's a location. X is 1, is y 0. What if I am at pi over 2 at this location? Well, at location 0, 1. What if I'm at pi? Well, we said that minus 1 and 0. What if I am location at 3 pi over 2? Well, x is 0, y is minus 1, and so on. So let me emphasize one more time. Try to get this thing under control by having a reasoning built in your mind for arriving at the answer, as opposed to memorizing. Our second best is memorizing, and the third best is looking it up, or depending on some calculator or something to do this. Okay, until next time, good luck and